Okay, everybody. This is Aaron speaking. There's that 3-minute countdown that I promised in the chat window there. Just making sure everything is starting properly and that you guys can hear me and see me, and giving people opportunity to get in here before we actually start the lesson. My name is Aaron. I've done the last two of these. The last one was on mesh to solid. This one's going to be on what's new regarding generative design in Fusion 360. So it's really going to be a lot about how to use generative design, because I think for a lot of you this is going to be completely new. So this is going to be a good opportunity for me to show you what it looks like when it's now that it's been integrated into the Fusion 360 interface. So a lot of great stuff there. A lot of makes it much easier than trying to punch it out to some external software that had a different interface altogether. So looks like I have about 2 more minutes left in the preamble. Let me go ahead and touch on a couple other things. Hopefully everyone saw the update was on Monday. It was at I think like 6 p.m. local time. Lots of great stuff in there, things like Derive. There's all kinds of CAM functionality that's been improved. On that note, I want to make sure to plug, Bryce is going to be doing next week's live stream, and I'm going to make sure to post a link into the chat. Here's the chat. I'm going to post that link. So next week, Bryce is going to be talking all about how you can use Derive, which is a fantastic new workflow for anyone who is going to be if you're going to take your files to maybe like the CAM workspace, it's a great opportunity and way to do it without having to export the file or break links that were there previously. There's all kinds of workflows that this has opened up, and it's going to just make everyone's life a little bit easier for everyone out there using Fusion 360, which I imagine you guys are all doing at this point. In addition, there's also the Autodesk University is coming up next month. If you are able to attend, I highly recommend it. It's a good opportunity to network, meet up people like us, meet other Fusion users, meet people from all kinds of different industries and walks of life. And it's a great opportunity to learn all about Fusion 360 and other things that Autodesk is doing as well. Looks like I'm down to 17 seconds here. I'm not going to have enough time to cover everything that I wanted to do, so I'm going to just ramble on a little bit longer. There is another giveaway this week, and let me adjust my gain on my mic. I think it's a little too high. I always do that. So there is going to be another giveaway this week, and just like last week, Eric Carlson won. The way that you win is by leaving a comment on this live stream after it finishes. I can't use the live comments, unfortunately, so make sure to, after this completes, leave a comment on this one, and you'll be entered into next week's draw. I'm going to do this week's draw live after I show you the prizes. It's things like this water bottle, Fusion branded water bottle, a little mobile speaker. I'm going to do this pretty quick this time. Some magnets, some socks. I love the socks. I don't know if you quite grasp how much I love those socks. In addition, a little battery charger for your mobile phone and things like that. So let's go ahead and do this week's draw. And by the way, I'm still waiting for Eric Carlson to get back to me. I'm looking for your address. I can't actually send you your prize until I have a physical address I can send that to. So Eric, if you're watching this, make sure to reply to one of my comments, or I left you my email address as well. Let's go ahead and do a quick draw for this. So I'm going to show my screen, and here you can see this is last week's event. All I'm going to do is I'm going to take the link from this and put in this random comment generator. Unfortunately, I'm going to filter for duplicates, so you can't just go write 70 different comments and increase your chances to win here. We'll just do a quick search. It's going to find 30 unique comments available to us in this draw, so I'm going to hit start, and it's going to find one. So in just a second, we will be able to pick the winner. It looks like it's Gary Ireland. So Gary, I will be hitting you up on your commenting back on your comment with my email address so that you can get in contact with me, and we can figure out how to get these prizes to you. But without further ado, let's get into the content this week. Let's get into generative design built into Fusion 360 and really a lot of the workflow considerations when you're doing something like this. So let me just check comments, make sure. Yeah, Fusion. They're not actually Fusion socks; they're Autodesk socks. So we're part of Autodesk. We got to figure out a way to get some Fusion socks, right? Okay, so let's get into this, and like I say, this is going to be all about what's new in generative design in Fusion 360. This is where we're going to start. So if you're watching the recording, I'll try to skip ahead in the comments. I'll leave a little option for you to skip all that preamble. Anyway, let's get into it. Let me show you how to work with this new workspace and show you some of the ins and outs and kind of some of the things to look out for as well. So let's go ahead and let's just show you. This is the product we're going to be working on. It's a little caster wheel. This is something that I'm working on for an AU class that I'm going to be a part of. It's a good opportunity to introduce a lot of the concepts related to this type of design and everything that goes into that sort of consideration. So all I'm going to do here is I'm going to use the drop-down under model. This is how you know to access all your different workspaces. Everyone in a commercial license of Fusion 360 should have access to this generative design. I do want to emphasize that is the commercial licenses, unfortunately not the startup or education. The reason for that is the cost associated for us to solve these. So there is definitely a push. Every single time we talk about generative design, we get 50 comments asking about how students can get their hands on it. And we are looking for solutions to this. Unfortunately, I don't know when or when that's going to come. I would imagine it will come at some point in one way, shape, or form, but we just need to figure out the way to properly do this. So if you're in a commercial license of Fusion 360, whether you're in a Mac or a PC, you're going to see this generative design workspace. So I'm going to go ahead and just click that. It's going to take me to this new workspace. And it should look very familiar if you've ever used the generative design tool before. It's a lot of the same workflow. If you start with the toolbar, you work from the left and you work your way to the right. And that's the same way it was really set up inside of the external software that we'd used previously. But there's some really cool additions and some fantastic new workflows that we can utilize because it's now been integrated into Fusion 360. So I'm going to walk you along with this caster example. So the biggest thing you need to do is you're not going to do a generative design on your as designed previously version of this caster wheel. We're going to actually make some changes to it to accommodate what this generative design tool is going to be looking for. Things like the preserved geometry, things like obstacle geometry, as well as starting shapes if you get into using starting shapes. And I will be using a starting shape near the end of today's presentation. Anyway, the first thing we're going to do is we're going to jump into this edit model dialog. If you've used Fusion 360's simulation workspace, this is essentially the same thing as simplify. Here you can do things like, replace with primitives, which I'll be doing pretty common here. You can do things like remove features, like, I don't need all the details in all these fillets, maybe for like this caster wheel that we're looking at here. And you can also use things like primitives. And I'll try to use every single one of these, a lot of these different options. I'm not going to use every single one, but I want to show you some really cool workflows you can do with this. So first things first is this wheel. I'm not designing the wheel. I'm not doing a generative design on the wheel itself. So I really just want to get rid of as much detail as I want, but I want to save the body or essentially the shape around it so that I can accommodate for that or I can use it, I should say, as an obstacle. So what I'm going to do is I'm going to use this replace with primitives option. This is a fantastic tool. Again, it's in that Fusion Sim Simplify. And the first thing I want to verify is, maybe the type or the primitive shape that we're going to use here. And then also I'll be looking at the way the axis is defined. So I don't really think a box is going to be good for this selection. So maybe I'll just click in here and get an idea of what this is going to do. It's going to replace that wheel with this box. So not the right shape, right? So we have some different shapes we can use here. And obviously there's a better shape type for what we're looking at here. I also want to verify the object type. I don't want to do it on a body necessarily. I'm going to use this drop down and change it to a component instead because the wheel component itself is comprised of a couple different bodies. It's the rim piece and also the outer wheel piece, and there's actually also some small sleeves for the shaft that goes through it. So I'm going to change this to component so it gets all the different bodies related to that component. I'll select the wheel again, and there's that big ugly box that we're looking at. Let's go and change this to a cylinder, and then we'll just verify the shape direction. So if we look at our triad up here, it looks like I want to use the Z direction, so I'm going to change this shape direction to use that Z axis. If I rotate around, I want to help you visualize this. Let's go ahead and just use our right view. I'm using perspective with orthogonal views. It just makes it a little bit easier to visualize here. And what I want to make sure of is that this doesn't go, too far outside of the wheel, but I don't want to have it, be totally flush with it, because I want to build in a little bit of tolerance into this. So I'll go ahead and just drag it out until it's a little bit past that shape. We could always do things like measure and get it very, much more precise as well. But just like that, it's able to replace this complex wheel with a very simple cylinder, which is going to help me a lot when I go to run this generative design. It's also larger than the original part. Like I say, this helps me deal with things like tolerances and fit and all that stuff. If you wanted to, you can go and you can add a fillet in this workspace. So I'm just hitting F on my keyboard to access my new fillet command, which, by the way, there's some nice things going on there as well with the update. Make sure to check the blog and the other video that's related to this to learn more about some of those other enhancements. But I'll just pull it back in a little bit, and that's looking all right. In addition, at the top of this, there's actually this cap, but within the cap itself, there's a bunch of different bodies, and I'll just hide the top body on here. You can see there's actually all the bearings, the bearing wheels that go along with this to enable us to slide freely. So again, I don't necessarily want all that detail. I do want to make sure to preserve that area though. So we'll do something here again. We'll just do a replace with primitives. It should keep it should remember the previous selection and options that I used before. So you can see that I'm going to use my component selection option. I'm going to use the cylinder shape, and instead of the Z-axis, maybe I'll use the Y-axis instead. Again, it makes it larger than it needs to be, but we can drag this back, and we can get this pretty close to the original shape. But I don't want to be too close. I want to build in a little bit of tolerance into this. So just like that, we've replaced two very complex parts, and now we're moving along and setting up these obstacles and preserves. And I should mention that like the Simplify workspace in simulation, this edit model area within Generative Design is independent of the original design. So we can do a lot of design exploration here without worrying about affecting the original design. So some nice stuff there. Just checking comments, make sure you guys can all hear me still and that you're paying attention. Looks like we got people paying attention. That's always good. Okay, so let's go ahead and move on to the next step. And what I need to do is I want to pull off pieces of the original fork shape here to then use as like a preserve area for the generative design study. So if you think about this, I need to be able to attach to the shaft. So I need areas, around this section here on both sides to be able to slide that shaft through. I need somewhere to attach this to. And at the top, let's hide that simplified primitive that we just created. There's that groove for the ball bearings. So we need to actually preserve that as well. And so I'm gonna do this in two different ways in this case. So first thing I'll do is I'll just right click on the fork, and similar to any modeling workspace, we can use things like isolate to really kind of focus in on this one single part that I'm going to be working on. And I'm going to do this next step in two separate ways, and the reason for that is just to show you more different ways of accomplishing what we're trying to do here. So the first thing I'll do is I'm going to hit S on my keyboard. This is going to bring up my shortcuts, and just to help me get to this a little bit quicker, I'm going to type in offset. I use offset faces quite often when I'm using this generative design, because I basically just need to copy these two surfaces and bring them and create some body to use for these preserve regions I've been referring to. So I have those two bodies now. If I've created them, you can see they're now contained within this bodies folder in the model components in the browser there. On the top of this, I'm going to do the next piece in a slightly different way. I'm going to just use a primitive cylinder. I'll just go ahead and select that face, and I want to center it. Looks like we have that nice little pop-up there that enables me to do that. And all I want to do here is I want to just slide the cylinder into this body a certain amount. I want to make sure there's actually the pin that goes through the top there. It's actually, I think, press fit or something. We want to make sure to get enough of that material so that we can have an area for that press fit operation as well. So we'll drag this down a certain amount. And obviously I don't want to do a cut. I want to use a different type of operation here. If I use intersect, it's going to only bring in the area of that model that's being interfered with this primitive cylinder that I'm creating here. The reason why I didn't use this previously is that if I had done it with the other pieces down here, it actually consumes the main fork body, which is something that you might not want to do. And actually, now that I'm thinking about this a little bit more, I don't want to do this because I want to use that fork body as a starting shape later. So I'm gonna just cancel this. That's one way to do it. It's a way that I've found to be pretty handy, but like I say, it consumes the body once you do that. So I'm going to use an offset surface once more, and I'll just pull off a couple faces here. It looks like you got that chain selection in that last one, and so I'm going to just clear that selection real quick. I do just want to get the groove in the two other faces there, so make sure to check that chain selection option there. We'll click OK. These surface bodies show up as red in this interface, and that's because you can't use surface bodies for the next operation that we're going to be doing, the actual generative design portion of this. So I do want to make sure to now do another feature here. I want to thicken those up real quick. So I'll just use the thicken feature. And if I pull down on this arrow, I can start to, it's easier to visualize kind of down here where the shaft goes through this, the general size of this. So I can drag this a certain amount, and it's up to you how big you make these. I'll just go to this kind of rounded number there, click OK, and now we've created some more bodies to be able to use as preserve regions in the next step. So at this point, I want to get rid of things that I'm not going to be using in the generative design study. So I'm going to select the three surface bodies that I created previously, and I'm just going to right click and select to remove those. And in addition to that, I can do the same with the fork. I just need to make sure to find the body here. If I select the body and select remove, that's going to enable me to get rid of that piece. So let's go ahead and let's unisolate to bring back all the other pieces of this, and we should have created all the necessary pieces for the generative design. Now what I want to do at this point is I want to make sure there's no interferences, and this is partially my own. It's a good check to go through, but there's a really nice way of doing this within this tool. So I'm going to select this interference tool from the toolbar, and I'm just going to drag and cover all these different bodies within the graphics area to select all these different pieces here. At that point, we can go and compute this, and essentially what I want to make sure is that the piece being cut are these primitives that I created, because when I created the big cylinder for the wheel, it passes right through the shaft. It doesn't care where the shaft is. Even if the original part doesn't go in that area, these primitive replacement pieces are just that. They're real simple. So using this interference tool, we can very quickly cut, and this actually turned out very nicely. All the primitives are on the left-hand side, which is what I want. I want to keep any of the other pieces that we see on the right-hand side. So just like that, we can clear up any interferences. If we wanted to double check and verify this, we could do so. It even adds a feature when you do that, so you can see it actually does a combined cut essentially from that interference tool. So really handy. That is also in the Simplify workspace in the simulation side of Fusion 360. So I'm going to check comments once again just to make sure we're good. Looks like we're good. So with that, we'll go ahead and finish the edit portion of this, and then we can start to move on to the next steps. One thing that I could have actually done too is I could have just deleted this face when I offset the groove for the ball bearings, the balls for the bearing. It creates a groove on the bottom, obviously, because that's the way it was offset. If you wanted to, you could just select this and delete it with our cool, and powerful deletion methods that we can use, but not a big worry for me. It's not going to affect my results too much. Okay, so now we're basically moving on to the next step, which is to define things like obstacles and preserves. So I'm going to start with obstacles, and I'll tell you why I'm doing that in just a second here. So I'm going to select obstacles, and obstacles are things like the piece where the cap is, and that will still be in the next design iteration. The wheel itself obviously is a big obstacle, and also the shaft. The shaft is a different part. We do not want material or geometry to go in that section. So we'll select that, and we click OK, and all of a sudden it colors this red. This is the coloration that you should know should be, keep out, right? And it's red, do not enter. So the reason why I like to do obstacles first is that with those defined, I can go and now hide them, because you don't really use them for things like, structural constraints or loads or things that you'll actually be defining later to define a little bit of information about how this problem is going, or how this thing's going to be loaded, right? So at this point, I can go and I can, access my preserve geometry option, and we'll select all of this. And you'll notice I actually get the pin. This is an option where we could like consolidate parts, maybe if we're going to use like an additive approach to actually produce this. Or with the new export options, we could actually even remove this piece later if we wanted to, and use it as like a constraint potentially in the next step. So that's it. That's the preserve and obstacle setup and the model definition. The next thing I want to do is define an objective, and sorry, not an objective. I want to define loading conditions. So I'm going to start with a structural constraint. You can see I can use C on my keyboard as denoted in parentheses there, or we could define loads as well, and just like in simulation, it's C and L are the keyboard shortcuts. So I'll hit C on my keyboard. I want to fix this about this face, and that's it. That's really the only constraint I'll be using. You could also consider, like some sort of fixture, maybe where those balls are, but we're not going to worry about that at this point. It's just a simplified example of this. Next thing I want to do is define some structural loads, so I'll go ahead and select the option. I could also use L on my keyboard. And probably the biggest load is just, this reaction at the bottom of, if the weight is acting against this. So we'll go ahead and type in a value here to use as my magnitude. And this has been improved significantly over the external piece, because we can very easily change the direction. As you can see, I can use the triad handles to kind of rotate directions and in all the major directions. So very handy and nice to be able to use that. I'll type in 150 pounds. Maybe that's my design consideration, the layout that I want to use. And that's just one of the load cases. And what you'll find is that as you add more load cases to these generative studies, the results will get much more interesting. But part of that is that, that is not the only load case. Like if you look back at the original design, the wheel is, it's got a shape to it, and if it were to go up like an incline or something, maybe it would be acting, some of the force would be acting sideways, right? So what I'm going to do here is I'm going to quickly clone the load case. By cloning it, it enables me to avoid having to recreate the constraints, and I just double-click the load case from the browser there to activate it. You need to make sure to activate it as you're doing this. And actually, that brings up, okay, let me continue on with this, and I'll double-check as I set up the load case here. So in this case, as I was mentioning, the load isn't always going to act, perfectly, upward, right? There's times where it's going to be acting to the side. There's times where it might be pushing forward for whatever reason. It's just about, how whatever, this caster wheel is being supporting is being pushed around, right? And I'm thinking about my baby's Y bike. She pushes it, and she goes up like the lip from the hallway to the kitchen, and all of a sudden there's different loads acting on it, right? So there's a lot of things you need to consider there. So we'll go ahead and activate force 2, and essentially I'm gonna just go in and I'm gonna grab and slide things around so that it's gonna act, at some angle. I'm gonna define this 30 degrees to the right, essentially, just the way we're looking at it. And maybe I'll do a slightly lower load in this case. Maybe I'll do like a 75-pound load in this case. And there's different ways of defining the directions. You can also use things like vectors. For me, it's just so much easier just to use the arrows and to drag it around and to visually inspect from the graphics area. It's just it's been improved quite a lot by being integrated into Fusion 360. The thing that I wanted to check, and the thing that I actually had problems with, and when I was first setting up this problem, was I was going to select targets, and what it was doing, it was selecting the first face as a target, but then it was using the second face as a reference, because you can always change the reference direction to use. And so I ended up only loading it on one side, unfortunately. So some of those results were, garbage, but garbage in, garbage out. But in this case, I did actually get both the faces in the first definition, so that enables me to not have to go back and edit that. So that's always nice. Let's go ahead and clone this load case once again. And again, by cloning it, it enables us to avoid having to create like a new constraint. It also enables me to just reuse that force with the new magnitude and go the opposite direction. So we'll go ahead and go -60 just to flip it up. And we can, as we're dragging, it'll want to snap to those rounded values. And just like that, we've created 3 different load cases. Now we can move on to the next steps for one of these generative design studies. So we'll go ahead and select our objectives. And so we have 2 different objectives to consider here. We could do things like minimize mass, but also maximize stiffness. A safety factor of 2 is, little more extreme than what you'd really expect with like a caster wheel. So let's go to something like a 5 or a 3 or something that's nothing that you're going to need to worry about essentially. I do want to note that if you use maximize stiffness, you define a mass target. What we've found is that a nice way to find a mass target to use here is to actually run like a normal minimize mass study first, and then you use the mass from that to actually define the mass target in the maximize stiffness version. So some ways of thinking about how to come to these mass targets if we're going to use things like maximize stiffness. So 5 is our safety factor in this case, or let's go to actually like 3 is probably more realistic, but we'll click OK, and then we'll get into the manufacturing setup. So this is where you can do things like add, unrestricted, which basically means it's just going to generate the shape, and it's not really going to consider how this is going to be manufactured. There's also things like using additive. By selecting this additive toggle, it's going to use, the 3 major directions as like, the direction for print. Obviously, if you've ever done any 3D printing, you know that like the part orientation is very important into, how many supports are required and things like that. And that's what's being considered here with things like overhang angle and minimum thickness. So by selecting this additive option in the manufacturing constraints, it enables me to get 3 other results from this. In addition, these milling constraints are totally new to this release, very powerful. In this case, you can do things like include all 6 orientations for maybe the 3-axis setup. You can do up to 4 different setups here. And maybe you want to try to reduce the number of setups. So in this case, I'll just use the positive and negative z's, y's and z's. We could also do things like use a 5-axis definition as well. So in that case, it's not really worried about setup orientation. You can really, if you're using a 5-axis machine, you can do this in all these different directions. So the other thing to consider when you're doing this is to determine things like the tool diameter. And what you're thinking about there is not like your roughing tool, right? You're not thinking about your face mill. You're thinking about when you're going to finish this thing, what tool diameter is the essentially the smallest that you'll be using. And this is something that you'll be able to define here. And we're looking at ways of improving definitions here and adding more abilities so that it's going to consider more information about your machines as you get into using this. We'll go ahead and click OK to that, and then we'll get into things like the materials. And when this was added to Fusion 360, we got access to a ton of new materials. I will say if you do things like add air, you're going to see the pre-check's going to get mad. It's going to say, hey, your material is not going to work for you. So make sure to only use materials that you have all the correct definitions to be able to use. I'll just go ahead and delete that out. I'm going to just select maybe 2 or 3 materials here. I'll select maybe like a 6061 aluminum if we're going to machine this. Maybe like a alloy steel or something, just like a generic alloy steel. And at the bottom of this list, there's things like titaniums, which that could be used for like those additive cases. Okay, so with that definition, we can go and you can double check now that pre-check is now happy. I showed you previously there was a little issue there. It went to red, and that's because that air material does not have appropriate definitions to be able to solve this with. But with that, you'll go ahead and start to solve this. And this is going to solve on the cloud. It's going to cost 25 cloud credits, as mentioned. This is the big hang up with why we're not able to bring this to students. This is essentially our cost to run one of these studies. These are very complex calculations, and when we're solving these things, it takes quite a lot of time and quite a lot of power, server power to do something like this. So we'll go ahead and, I'm not necessarily going to solve this in front of you, right? So I could either solve this if I want, or I can close at this point. I'm going to just close because, like I say, I'm not going to have enough time to solve this in front of you right now. It does take, depending on your quality, and actually I should get into that. If you check under your settings, you'll have the ability to adjust the synthesis. So if you're having problems with maybe it's getting too thin or something, or you're working with a really small feature or something you want to capture, you'll take this synthesis. This is essentially like your mesh density. If you slide it to the right, it'll get more accurate. If you slide to the left, it'll get coarse. It's always going to cost 25 cloud credits, so it's up to you what setting you use here. If you use coarse, you'll get those results back much faster, right? So we'll click OK, and with that, I do want to show you something that's really cool about this new ability to use essentially the simplify workspace here. With that set up, I could also go and I can edit the model once again, and in this case I want to just clone the generative model. So what I'm saying here is I'm cloning all the work I'd done previously, which, by the way, is captured at the bottom of the screen in the history, right? So if you ever make a mistake in the setup, come use the history in this edit model workspace to make changes to that. So we're cloning all that information, but it's also going to take the study that we set up. So if you want to make like a quick change and try something else, or maybe add a new load case or change the geometry, well, if you're going to just change the load case, you could just clone the study itself. But if you're going to change geometry or change the model definition, you'll want to actually clone the generative model like I'm doing right now, and it will bring over that whole study that we'd set up. So we're active in Model 2 at this point, and what I wanted to do here is in this case, I wanted to suppress one of these features in the history. In this case, I'm going to suppress this removal of the original fork here. And the reason why I'm doing this is that I want to actually use this for a starting shape, because you can influence how generative design comes to a solution. It doesn't necessarily mean that your solution is going to be contained within this area of this starting shape, but it's something that you can use to try to influence how something is made. And it actually helps you overcome some issues that might occur if you have a case where maybe like there's no direct path between your preserves where it's being constrained and loaded. You could use things like a starting shape to give it like a direction to go to find its way around, essentially. So now we're basically, we've taken and copied the whole study. All we need to do here, if I wanted to use the starting shape in the second example, is just come to my design space, select starting shape, and then select the body. Starting shapes are going to be yellow. That's just the coloration that we've determined. And just like that, it's set up. Okay, so that's set up. One thing I would note here is that the study has taken the exact same name. So if you're going to be cloning models like I did just now, make sure to get in here and change the study name, because when you're looking at the results, it might not be totally clear what you're looking at. So I'll call this, study with starting shape, or whatever you want to call it. Just give it a new name so it's easier to find in your results when you're going to explore. And with that said, let's go ahead and take a look at some of this exploration and some of the work that we've created with a previous example. And like I mentioned, there were some mistakes in some of the setup that I did here, and that happens, right? But here you can see some of these results, and what's really neat is that you can sort by study, and in this case you can see it looks like I forgot to rename some of my studies, so learn from my mistakes. You can do things like isolate the ones that I've already exported, and you can see I exported this guy. You can just tell by the little icon that's right here next to the name, or not next to the name, but on the the image there on the thumbnail there. You can also do things like sort by manufacturing method. So maybe I just want to look at the unrestricted ones. I can isolate that very quickly and then just take a look at those. You can see I have some that did not necessarily converge, right? And this is a good opportunity to talk about, converged versus completed. On the top here, you can see all the converged versions, and that's because I'm sorting by process status. We could also sort by any one of these other items, but these ones that completed, if you understand the difference between converged and completed, converged essentially means it met all the design criteria and the objectives that you were after. Completed means it ran through some iterations, but it wasn't able to find a solution. So in this case, I've scrolled over one of these, and you can see it says it can't reach the objective because of blah, blah, blah. Make sure to take a look at that, learn from that, make a change in your next study, and set it on its merry way again. So another thing you can do is if you want to we'll reset that view real quick. Another way to kind of filter through some of those very large caster versions, we can use a slider down here, and this will kind of get rid of some of those ones where it may have completed but not solved completely. So you can use this slider to kind of filter through. You can also use your factor of safety options as well. This is just one way of looking at these results. There's tons of results I have access to, and this is related to the number of studies I've run here. If we take a look in the next tab here, you can see all these different parameters essentially associated with each one of these. So you can go and sort by or find one that has a particular material maybe, or other ways of sorting this. I'm going to jump over to the table view. Essentially, this is the same thing. Very easy to sort and kind of go through. Finally, there's the scatter plot view. Really handy to be able to visualize this. As you scroll over each one of these little dots, you'll actually get a preview of what we're looking at over there. And what's neat is you can take and you can let me reset the zoom there. You can go and zoom in on a particular area. You can see it's broken down by materials with the coloration of the dots there. And we can go and reset this, and we can select up to 4 of these and start to compare them. And I'm just selecting these kind of at random, but we'll select 4, and then once they're selected, you hit the button, you'll be able to compare these 4 results. Oh, I think I might have selected too many there or something. We'll just do 2 in this case. So there we go. We've selected 2 of these. You can kind of see that you're able to rotate and visualize this. Obviously, this this one on the right and potentially the one on the left is one of those ones where I only loaded one side, unfortunately, because when I was setting up the loads, it changed to reference, unfortunately. What's neat about this comparison tool is that it keeps the view standard. In addition, you can view and visualize, where the highest stresses might be. You can also do things like view the design space. So here you can see, the design space and what we mean by that are things like the preserves, obstacles, and starting shapes as well. So it gives you an idea when you're sorting through tons of results, and maybe you're using all kinds of different preserves and obstacles and starting shapes. This is a great way to really get through those results and find, some really fantastic versions. So jumping back to the first tab, this result right here, this is my latest iteration, as you can tell by the naming, and I always just use really bad naming nomenclature, unfortunately, but let's go ahead and clear that selection there. What I wanted to show you here is that each one of these results, and man, this one, I'm really happy with this. Looks great. This is definitely not one that I would consider was using a milling constraint, and that's what it's showing me here. It's just a organic synthesis using unrestricted. But what's neat about this is each one of these solutions presented to you actually has like the full, not the full, but a certain number of iterations that are saved out. There's actually like thousands of iterations that go into one of these generative studies. So as I slide through this, you can visualize, how it's going through each time it saves. You can visualize these different results, and any one of these results is something that you could save out at any time. So if you find one that maybe isn't necessarily the last one that you like, that you want to use, then just, grab it and export it. With that said, when you go to export, it's gonna enable you to now create a new design from the outcome, which is super handy. Previously, you'd have to create the ACES file and then bring it back into Fusion. Here you can see it's going to cost 100 cloud credits to export this. You should really only have to export one of these when you're running these generative studies. Generative is essentially provided free with your Fusion subscription. So, this is the consumption model that we're using in bringing this product to market. What I'm going to do here is I'm going to come to the last iteration. This is the one that I actually exported. You can see it's right at the factor safety target. When I click this button, it's going to enable me to then open the design. And this is where some more of these really, really fantastic new changes have come to Fusion 360 in this last update. It does take a little time. This is a pretty complex model. The actual, when you go to create the design from that button I showed you previously, it takes 10, 15 minutes depending on the model. So some things will happen there. But once it's exported and open, like I've done here, you can see it's done a very fine job of preserving the areas where the shaft will need to go through. We have clearance for the wheel. We have the ability, an area for those ball bearings to attach to, but also an area where this actually the caster will connect to whatever it's rolling around. What's really, really fantastic about this is that there's the full design. There's a design history essentially. Maybe not full. Maybe full is not the right term there, but what you can see it actually does there is it takes the preserves, right? It needs the preserves. There's no ifs, ands, or buts about that. You define those as preserves. So the very first feature you see in there is just basically a body, series of bodies from the preserves. There's also the obstacles are brought into this design history. From there, the T-spline body that does all the craziness between the loading areas and the fixtures and things like that, and figures out the way to get there and have the correct strength ratios and everything. That's the next feature that gets added, and then there's a boundary fill that basically connects all those, and then essentially there's a combined cut from the obstacles that we had used previously. So. What's really fantastic about this is that if I wanted to make a change, I can go and I can edit this T-spline now. So this is fairly new to this tool. There are some new tools in sculpting in general. So this isn't necessarily limited to anyone who's to only those who are exporting generative designs. What's neat is some of these selection options are new. The whole strut selection is super handy. Essentially, I'm just going to select a face, and then I'm going to hit Control H. It should select that whole strut, and now I can go and I can start sliding this around. As mentioned in our What's New video, this triad orientation isn't really that great for what we've selected there. So there's a new option to adjust the coordinate space per the entity. So if I select that, it actually adjusts that triad. So it's actually going to enable me to adjust this maybe along the axis. Some very nice things about that. And in addition, there's things like the ability to delete holes. Some of these designs you might be doing with generative might be for aesthetic reasons. So sometimes you want to come in here and make changes. In this case, I'm going to select this guy and use that feature selection once again. Maybe not that selection. Maybe I'll try this side. I haven't actually tested this with this, so bear with me. So when I selected the left side, it wanted to get the strut, but because I selected the right side that time, it actually got the hole. So that's nice because I can now use things like this erase and fill tool, which will fill in that hole. You have a couple different options on how you want to do it. You can do the reduce star or the fill star. I'll just do the reduce star, and just like that, it should close down that area to make it more solid, and we have some things that we could do with that now. I will note that, and I did note this in our update video, that These ones are showing slightly different, and the reason for that is that they're frozen. At any time, you can always go and unfreeze these. So it's just an option that you have. If you like get to a particular shape you're after, you can freeze or unfreeze. So here you have the ability to unfreeze. The reason why those ones are frozen is because that's where it interfaces, right? So there's some things going on there to connect that to that piece. So I think that is really what I wanted to cover today. 46 minutes is about what we shoot for these live streams. I do hope that was valuable for you to see this stuff. Let me go ahead and show my face again. I really love to show my face. We're getting some new equipment. We're getting a new camera to be able to see my face better. Like I mentioned, actually next week it's going to be Bryce, so you'll get a new voice. I know you guys might get tired of hearing me drone on. I want to thank everyone for watching. If you like this, give it a thumbs up. Make sure to subscribe to our channel. We are having another one next week, next Tuesday at 10 a.m. Pacific time. Bryce is going to be going into the derive functionality that is new in Fusion 360. Really incredible for a lot of different workflows that you might need to get into. So I think with that, we'll go ahead and wrap this up, and I'll look through the comments to see if I have any questions I need to answer. Leave a comment on this, and you'll be entered into next week's draw. Thanks.